Let's actually walk through this process and actually create a tiny Git repository. Certainly, if you are working on an open source system or you're bringing up your own open source system, this is how you're going to do this. Let's just create that and change into that directory and do there was no files in it, git init dot. And it says that it implemented an empty one. And you'll notice that there is a Git directory. If we look in that Git directory, you'll see that there are files like, let's edit. I don't recommend that you change this by hand, but this is what's in git config. And at this point, it just lists some particular options. Later, we'll take a look at it after we've attached it to GitHub, and we'll see that there's some more stuff written in here. Generally speaking, if you want to change that file, there is a git config that gives you a set of options so that you don't make a goof up that file. It's kind of important that it works. But that's what's in it, and it just has some directories and some files. And we're going to add files to it, build a branch, stuff like that. But right now we have created a Git repository. Now, at this moment in time, it's not shared with anybody. It's just on your computer. When you create a file in it, it's going to go through a couple stages. And first we have to have a file. We're going to create one with just some text in it. But those stages are where it is staged to be committed and when it's actually committed, and we'll see how we do that. Let's also recognize that Git is basically the ultimate backup system for your source code. And basically, when I start out a project, I will start out with usually some sort of an outline, a design you may want to call it. Lots of stuff doesn't merit the level of a full-fledged design. I may be building a little tiny tool that's only 50 or 60 lines. But I'll write down a sentence that says, this is what this is, and I'll usually stick it in a README. That's for my own future use so that I can find it later and see what it was that I did. And the first thing that I do is I create a Git repository in that directory and I add it. I do this even if I have no intention of ever sharing this with anyone else in the world. And this is just, this is the process. It makes certain that as I'm doing this, I've got an accurate record for my own future. So let's do MD is Markdown. I use two different things, Markdown and ADOC format. But Markdown is good for a lot of simple stuff. So I have created a little title in here and 3 lines, and that's what's in the file. And the first thing I do once I create it is, quite often if I do this, we'll come back to this, but it'll tell me that I haven't committed it yet. But I'll do git add and the file name and git commit and give it some sort of a decent message. And now if I do git status, it says that I'm working on a clean tree. So it refers to everything as a tree. It's actually a directed acyclic graph, but these are a particular kind of trees. And I now have this checked in and created in Git, and I'm a Git user right there. That's kind of all it takes to get off the ground with Git. And you install it, you create a repository, and you start using it. Now let's add to this file. And I committed it already, but let's go and make a change to the file and see what happens. And yeah, it's telling me that this particular file that I have is modified, and that it gives me that I can do a git add to record the changes that I've added to that file. So that is kind of the real beginning stuff. Let's actually change that. And I've shown you in the comments here how to have both a short and a long comment on it. If you have an editor configured, you could do this easier by just doing git add and then git commit. I have my editor configured so that it'll bring up in the editor. And this is one of those configuration things you can do in Git. It'll bring it up in the editor so that I can put in a title. And what you want to do is actually put in a title and some meaningful comments about how you changed it, why you changed it, what the reason for this change is. And these don't seem to make any sense, when you're working on your own project and it's just you by yourself working on it. But when it's a bigger project or you're coming back to it 3 years later trying to go, what did I do? Why did I do it? It'll make a lot of difference. And you just have to trust me on that one. But for instance, I'm developing classwork for a class for the fall right now. And there's a tool that I wrote last semester. And I would not have been able to find that tool on my own file system if I hadn't used Git and put in comments in a README that said, this is where that tool is. And I spent several weeks working on this visualization tool. But this is the stuff that allows you to deal with the frailties of your own memory as well as allow you to share stuff with other people. I have files and tools that I wrote 20 years ago that I'm still using. And all of this stuff is in source code repositories. All of it's now in Git. But when I want to go find the source code for one of these things, let's say I have to recompile it, that's where I'm going to go looking, is in these READMEs and in the source code control system. So this is long-term commitment, and this is how you build stuff and track it. Now at this point, if I do git status, it'll tell me again I've got a clean tree because I committed it. And what has happened inside the Git directory? This looks kind of the same, but if I look at all the stuff in there, you'll see that now it has these Git object files, like that one. And those are actually the changes over time that you're making to stuff. And it has some sort of an index that it allows to say the master version of this and that stuff is tied to these hashes. Okay, this is actually a hash of the change itself. So because it's a hash, it becomes almost impossible to make changes without it being obvious that you've broken the Git repository. So don't go in the .git directory and randomly make changes. It will just break it. You have to use the tools. And at the end of this, I've got a list of which tools I've actually used over time. But that is kind of the set of stuff you do to add and make changes. Now, if I do git log, log actually lists what the changes are. And it gives me these commit hashes. Those commit hashes are how I get to things back in time. So if I know that I want to go back to a particular thing or I want to see it, I can use that information to travel in time back to it. I rarely do that. It also tells you who the author is and what the date is that this happened. Now to get that author stuff correct, if you just go in and create a Git repository, I've already got some stuff set up. It's going to tell you you've got to use git config to set some things. But once these things are set on your computer, you're pretty well good to go for a long time. And it's just basically git config this particular named item and some string, like what your full name is, what your email address is. So you need to do that when you're first setting up your own Git system for the first time. Now, I said it's a directed acyclic graph, and it uses branches. The first question is, what branch are you on? And the easiest way to find out is git branch. Let's do that. And it says that I'm on the branch master. Master is kind of a special branch. It's the central trunk of your your directed acyclic graph, your tree of changes that you have. And in lots of projects, you can't just change master, you have to create a branch. This would be the normal thing. You're working for a business, they have master, which is the released version of a piece of code, and they're not going to just let you willy-nilly go in and make changes. They've got some sort of process that they've attached around this, but underlying that process is the source code control system, and that source code control system says, by golly, you can't change it. Probably only the owner of the system can make that change. But we can check out and we can create a branch. And a branch is a set of group changes that's on a name that you're working on. You've got a customer defect. You're going to go fix it. Okay, here's the workflow that is kind of normal. You know, the quality assurance team has tested it. They've got the main branch or the master, but somebody has a defect. Okay, they log the defect. They add some stuff to the defect. This is in some defect tracking system. They've done some tests. They've figured out this is really a problem. It comes to you in development to fix this because the management has scheduled, this is important, this has to get done at this point in time. There may be other defects that they're pushing off, or you know, they're not relevant to you, or they're not in your section of the code, but you end up with this thing. And you're going to take it and you're going to fix it. So you go, you get a copy of the master, however you get that, and you want to create a branch. Because you're not going to make changes in the original, you're going to make this branch, you're going to make changes. You make the changes, maybe it takes days, tests, you have to add unit tests to it, you've got to fix some things in the code. So you've got a whole series of steps that you go through, and then when you get done with this branch is going to get passed on to somebody else to do code review, somebody else to do quality assurance, and eventually this branch is going to get dispersed to the customer. But through that entire time, you're making changes, you're adding stuff, you're adding documentation, all sorts of pieces that go into it besides just the code. And you can track all of that stuff on that branch. So let's create our first branch. That -b says I'm creating the branch. That's important because we'll do checkout without the -b later to just switch back and forth on branches. And you give it a name. I'm not fond of names that have spaces in it, so I put minus signs. And I think you'll find that most people will agree with that kind of an approach, is whatever words with minus signs create a branch. At least, I haven't seen any businesses that don't like branches named like that. But there are plenty of them that just despise people that put in spaces in their branch names. So, we check out -b our first branch, and now if I do get branch, you'll notice that it no longer shows that you're on master up here. It shows that you are on your first branch. There's a little star and it's in green. So we've switched over to a branch. If we do get log at this point, you'll see that head points at my first branch and it has master up there. So it actually knows that you're on a branch. Now you can create files on this branch. You could modify existing files. We fix something, and let's create a file. Okay. I'm just going to put a letter in it, but we have this file. If I do get status now, it'll show that I have an untracked file. This file, branch dtext, isn't on any branch, it's just out there. Sometimes you have files that are not related to stuff. Lots of times you have files, but this one we want on the branch. So let's add it. And let's also add the README so that we've got both of those on the branch. If I do get status, you'll notice now they are in green. They are staged, they are not committed. But let's actually add them to the branch. And once I've added it, I'm back to a clean tree and I have a branch. Now, at this point, there's an old version of the code and there is this branch off to the side that has things on it.